Hey everyone, how's it going? I'm here today to answer the age-old question, why is the sky blue? And as a bonus, I'm also going to answer the age-old question, why is water blue? And just to throw in an additional bonus on top of that, I'm also going to tell you why the sky is red at sunset. So, why is the sky blue? A lot of times when I ask that question or when people answer it for me, they tell me the sky is blue because it's reflecting the water. And then I say, well, why is the water blue? And they tell me that that's because it's reflecting the sky. And I always felt like that's a pretty circular logic. And in addition to that, neither of these things are actually blue. So where does the blue come in here, right? I've got two glasses for you. On the right, it's a glass, and you can tell me if it's half full or half empty, but it's also got water in it, and the water's clear. And on the left is a glass, and you might tell me it's empty, but I'm going to tell you it's full. It is full of air. And neither of them are blue, are they? So, how is it that we get a blue sky? How is it that we get blue water when very clearly these things are clear, colorless substances? And the answer comes from the electromagnetic spectrum. So what is light? Light is a form of energy. There are other forms of energy that we can't see that are also related to light. So radio waves, microwaves. You can have high energy light like ultraviolet, X-rays, and gamma rays, which my head is covering up on this. So that's the electromagnetic spectrum. And within the middle of it, you have visible light. Now, light coming from the sun is white, but if you shine it through, I don't know, like a prism, or if you don't really have a prism handy, maybe you've got a lot of water droplets up in the air. And if you shine the light through those water droplets, they'll split that white light and you'll get a similar effect, which we call a rainbow. So you got those prism-like water droplets dispersing the light with different energy. And if you look at this rainbow, going from left to right, you have red, orange, yellow, green, blue, indigo, violet. Now, if you have trouble remembering that, I've got a simple mnemonic for you, Roy G. Biv. Now, he's also one of the founding members of the band Bell Biv DeVoe. He's the Biv in Bell Biv DeVoe. So Roy G. Biv, Colors of the Rainbow. Okay, I made that up. There was a band called Bell Biv DeVoe, but I made everything else up. Oh, and I didn't make up about the red, orange, yellow, green, blue, indigo, violet. Roy G. Biv. Bam, you're welcome. You'll always remember it. Now, the red light has a higher frequency. The blue light has a lower frequency and more energy. And what that means is that when the light bounces off the top of the atmosphere, the only light that has enough energy to get back into our eyes is the blue light. And water is actually the same way. So if you shine light into water, if it's really shallow and you shine light into water, you just see what's at the bottom of the pool, right? You just see what's at the bottom of your cup. But as the water gets a little bit deeper, you get a similar effect. Less and less of the light is able to reflect back out of the water and into your eye until you reach a point where you can only see one color. And that's that beautiful deep blue. And if you keep going further and further and further and deeper, well, you know what's going to happen? You're going to have no light coming out. And then the water's black. And that's the deepest and spookiest water there is. You'll also notice that the water is black at night because we don't have any blue light shining on it to see that color. But this doesn't explain to us why we get these beautiful, beautiful reds at sunset. Why does the sky turn red at sunset? Well, remember what I told you about our buddy, Roy G. Biv? That's right. Roy, the R stands for red, right? The B, blue, indigo, violet, let's just all call that blue. And at nighttime, everything gets flipped because of an interesting effect in optics. Now, if you shine a light through a curved lens, It creates an image that's upside down. Now, the image that's upside down when we have a beautiful, beautiful sunset is the image of the light that's getting reflected back to us. So normally we lose the reds, all the oranges, all those yellows. Normally we lose them off into space and the blue gets reflected back into our eyes. But at nighttime, as the sun sets around the curved Earth, the atmosphere acts like a curved lens and it flips that image. And what do we see? We see the reds and the oranges that normally we don't see when we look up at the sky. And because normally we're seeing the blue, right? So we go from that blue, which I'm going to tell you is beautiful, and we just flip the energy sequence. We go to red. And that's why we get these beautiful, beautiful sunsets at night. So the next time you see a beautiful blue sky, or better still, a beautiful, beautiful sunset, be sure to thank the electromagnetic spectrum. I know I do. So have a nice day. Peace.